Hello and welcome to Module 5. This is Analyzing Data. So Module 5 is a part of the 12 modules in the ClickHouse Developer Learning Path that we have. So we've created our tables, we've got data in, and now it's time to analyze the data. And a big part of what we're going to do in this learning is talking about functions. Now ClickHouse is a SQL database. You can write SQL, take your favorite SQL query and run it on ClickHouse. But what makes ClickHouse way more interesting are the 1,500 functions that we have available between regular functions and aggregate functions. So that'll be a big part of what we talk about in this particular training course. Let's get started. Let's look at how to analyze data in ClickHouse. And we'll start with writing queries. I mean, that's really what it's all about here. It's a SQL database. You're going to write select queries. And it should be, if you're familiar with SQL, it should be very familiar to you to write these kind of queries. You'll find out very soon or very quickly as you use ClickHouse that you're probably going to want to use some of the built-in functions. And so I'll actually spend quite a bit of time on that. I mean, I don't want to just sort of sit and talk about SQL, but obviously, there's, if you just want to see how many rows there are in a table, that's easy to do. So if I select star from UK price paid, and I forgot how many rows. That was like 28.7 million rows. I mean, you're asking analytical questions here. So maybe you want to find out which town had the most properties sold. So maybe I'll just, figure out the count, and then if I group by town, I have to group by town if I'm gonna put town in the select. And then let me order by the count descending. So we'll see what the top, we'll see what the top 20 are. This shouldn't take too long for ClickHouse. Yeah, that took less than a second to process all 28.7 million rows. And yeah, probably no surprise. I suppose since 1995, London has had the most transactions. It looks like 2.19 million property sales in London, followed by Manchester, Bristol, Birmingham. These are probably, I assume these are the bigger cities in the United Kingdom. So like I said, that's a very analytical type question, very analytical query, select queries. So we do that quite a bit. Oh, I was going to show you this. Let me just take that query just for what it's worth. The output in the SQL console shows up in this nice table down below. But if I go over here to my terminal, I have the exact same I'm connected to my cloud instance here, but let me change that. So instead of, let me get rid of the, the limit's fine. Let me change the format. So for example, any of the output formats, all the output formats that we talked about in the previous lesson where we talked about input and output formats, sometimes it doesn't, in this example, it wasn't that interesting, but if you get an output that's got a bunch of columns, then the vertical format can be super handy, but you can put it in any format you want. I can do something like JSON each row. I can do CSV with names. I can do Parquet, which is a binary format, but I can still dump it to the screen. You'll kind of see what it looks like. So I just wanted to show you that the ones you're looking at that you normally see, like the pretty ones, are just output ones. That's nice. I mean, there's all kinds of different ways to do it. Okay, so I just wanted to point that out. It's definitely worth being aware of. And before we get too far along in writing queries, I just want to point out that ClickHouse does have it has support for common table expressions, so CTEs, where you put a with clause before the select. And on the left here, I'm defining London as an identifier. So the variable, the value of the variable goes first, and then like here, London is something called my_town. And then down below, I filtered by my_town. That's a very simple example, and certainly, I mean, there's plenty of reasons to do that, I suppose, but the more interesting one is definitely the one on the right, where you write a query. This actually executes different. It's almost like it is very much like a subquery, where in this common table expression, the variable name goes first. I called it most expensive, and then the as keyword, and then you can write any query that you want. And here I selected what did I select? I selected the top 10 properties by price. These are the most expensive, the top 10 most expensive transactions of property sold in the United Kingdom since 1995. And I took the average of those. You can see that down below, I took the result from most expensive. So here I just have a query that it's basically the same one that I had done before, where I selected the town and the count. You know, if you run this query, just copy and paste it down here. You know, you can't just add columns here unless you group by the columns. Like this isn't going to work. I'm going to get an error down below that says district is not an aggregate function and it's not in the group by, so it doesn't really make sense. ClickHouse has a great function called any, which grabs any district. So assuming that a town, I don't know what the logic is. I don't know if a town is bigger than a district or vice versa, but assuming, I should probably, yeah, I don't even know if that makes sense, but I just grabbed a district in the town of London. You know, it allows you to get a value. I suppose if I did it this way, if a town consists of more than one district, then it would probably make more sense to switch that around, because then you get the same, then there's only one result. Like Birmingham's the town, that's also the district. Wakefield is a town in Leeds, I assume. That's probably how this works. That probably makes more sense. So anyway, I'm a big fan of the any function. So just sort of, you'll see that in examples as we go through here. You know, standard SQL, take your queries from your favorite database that you've already written and try them in ClickHouse. But like I've already said before, we often ask different questions than you do in a transactional database. And almost always you're going to take advantage of the functions. And so that's what I'm going to focus on next. ClickHouse just has a lot of functions and they're super handy. And they're broken down into categories. If I go over to the docs, you can see it very nicely on the SQL reference page. Under functions, you can see we have regular, aggregate, table functions, which we discussed in detail in the previous module, module 4, inserting data. And window functions, these aren't functions that you call that return a result. These are SQL window functions, which isn't necessarily what I'm talking about. If you're not familiar with window functions, there's some examples here in the docs. You get to compute values over a subset of the data or a moving window of the data or something. And so you pick a column to partition by and then compute something here. Like I can just do an example here really quick. I'll just, like, you can find the average price of properties over a given column. Like, so for example, I could partition by the first postcode. So there's these two postcodes. And then I can just grab all the other columns, which is kind of interesting in ClickHouse. You can select star plus other values if you want. So this will be the average price of all the homes over whatever the postcode one is for each of the rows that I get back. So let me look for, I can just filter this out. Like, let's say we're looking for homes that are terraced, which is a special kind of home in the UK. And I can just put a limit on here. We'll do like the top 100 transactions or something. Or it won't be the top. Well, yeah, no, it'll be order by price descending. So it'll be the most expensive properties. And then you can kind of see if they got a deal or not. Like, you know, this property here is a lot at 69 million. The average price over that postcode is 6.4 million. So that's a very expensive house. I can scroll down. Let's see if somebody got a deal here. This house was, or this property, I should say, was like 16 million and the average price was only 1.73 million. So very expensive. Now I ordered by price descending. I should see what it looks like without that. I'll just grab a random 100 properties. Yeah. Okay. So if I do that, I get some pretty old transactions and these people got pretty good deals. So this is the average price over all homes. Oh, those don't have postcodes. I should filter by postcode 1 is not equal to an empty string. There we go. That'll be more interesting. This property was 157,000 and the average in that postcode is 317,000. So this house is a pretty good deal. I guess I don't know if it's a good deal or not as nice a house, whatever it is, it's below average. So that's that's a window function. I'm going to actually kind of go through some regular functions and aggregate functions just to give you an idea how they work. I won't talk about table functions because we already did. Lots of regular functions and they're all listed here in the docs. It's kind of intimidating when you go to the regular functions to get a sense of how many there are. So for example, they're in groups. We have the arithmetic functions together on a page, and these are like math, the math ones, you add, multiply, divide, absolute value, greatest common denominator, sorts of things. If you're working with arrays, we have dozens of functions for working with arrays. If you're working with dates and times, well, we have some great functions for working with dates and times. And we just, like I said, there's dozens and dozens of them. certainly can't like go through all these functions, but like I said, I do want to give you an idea of how they work. So the regular functions are the ones here. Let me click on the string functions. Those are nice. They do things to strings that you might expect, like, you know, what's the length of a string, upper, lower case. We could do that. Let's do the lower, let's lowercase the town from UK price paid. I better put a limit on that. We'll just grab 1,000 rows, and there's just 1,000. I could do distinct, I suppose, so we don't get the same value more than once. And there's a bunch of town names, all lowercase. So the regular functions work on every row, one row at a time. The aggregate functions return, typically, they return a single value. So for example, if I want, I don't know, let's just do a big one. Let's sum up the price from UK price paid. This will be a huge number. This is 28 million transactions, and I'm just going to add them all together. So notice I got back one value. So those are the aggregate functions. Let me see. I'm curious to see how big that is. That's way too big for me to figure out without formatting it. That is 6.38 trillion. I suppose the currency would be pounds in the United Kingdom. So those are the aggregate functions. That's kind of the difference between the two. I don't have, I'm not even sure which regular functions to show you. So my hope is that you will become comfortable looking at the documentation for whatever it is you're trying to do. You know, like I said, if you're working with dates and times, go to the dates and times page. Look for all the functions there. You can search the docs too. If you think there's a function in particular that you might want. There's a bunch of functions for working with JSON. Lots of functions for maps. I showed you the array ones. The string ones are so many that we have them like on 3 or 4 different pages. Like you can search in strings, you can replace values in strings. Again, that only does it on the result set if you replace a value in a string. Searching in strings is nice. I mean, ClickHouse is pretty cool. I have some of these on the slides, but I can just run some of these. You know, if you run for, or if you search for, sorry, like let's see how many properties there are in UK price paid, where the street name, so there's a function called position. Let me show it to you before I use it. That was one of the first, I think it is the first one. If you go to functions for searching in strings, you know, there's like 30 of them or something. They all have this format, this kind of model of the needle in the haystack. So the thing you're looking for, you pass in first, or the thing that's being searched, you pass that in first. The haystack, you're looking for a needle, so you pass that in second. And if this doesn't return 0, that means it found it. And it shows you where in the string that it found it. So if I search every single street name for something, like they're all capitalized. So let's say search for KING. This is in every single street name. Oh, I got to put like a conditional there. Like greater, if it's 0, it's not found. So if it's greater than 0, it would be found. There are 279,895 street names, streets in this table, where that column has KING somewhere in the string. But what I want you to sort of stop for a moment and realize is that I just had to process, ClickHouse did, 28.7 million rows. It took 105 milliseconds. And I don't really even have that sort of big of a machine here. It's just, you know, it's just a development instance. So that's just crazy how fast it is. We have a great function called multi-fuzzy match any. And it searches for, you have to give it an edit distance. And so like if you put 1 there, that means it'll search for all of the values, or it'll search for KING, but any term that's 1 edit distance away from king. So if the K is an R, RING, that'll be a hit. If the I is a O, then KONG will be a hit. Any of those 4 characters can change, any of the 4 characters can change to any other character, and it'll be a hit. Let's see how many I get. I mean, it's just amazing. So 28 million street names. Took 94 milliseconds to not just check to see if they equaled king, but if they had some subset of it that was 1 edit distance off of king. Fascinating. That's really cool. All right. So lots of searching here. You can do all sorts of fun things with strings. I have a nice one on the slide. Let me go over here. Oh, I missed the date and time ones, but I'll come back to those because I want you to see some of those. The string ones, like I said, they fit in different categories in the docs. Here was the king one that I did, and here was the fuzzy match with the king. This one's multi-search, all positions, case insensitive. It's a great function name. It's a super long function name, but it tells you everything you need to know about this thing. We're going to search multiple terms. So we're going to search for Abbey Road, both of those in street, and they're going to come back as an array of positions. So positions is going to be an array. And notice in the where clause, I'm using the has function, which is an array function. And if there's a 0 inside there, that means Abbey or Road or neither one of them were found. So if there's no 0, notice I put where it's not, that means both Abbey and Road must have been in the word. And so if I run this function, here, let's go over here and run it. And I can just copy and paste that one. That's a lot of typing. We'll get back a bunch of street names. Well, Abbey Road, that's the big famous one. But Abbey Field Road, it looks like there's 30, I'm just scrolling really fast, 30 street names that contain Abbey and Road. All right, nice. Fascinating that only took 200 milliseconds to process that many rows. And the date and time ones are also great. If I go back to the slides, you'll notice I had some, just a kind of a mention of some of these functions. If you have a date, it's just, it's nice. You can convert them to all sorts of different values. You can, let's say you're computing events and you need to make a bar chart from the last day or something. Every day you need a value. You can group by those values very easily. If I go over here and select if I want to find the most expensive house, let's say I want to find the maximum price and the day. So I do, let's do to start of day, and then the date field, and I'll just call that day. And I don't want it to be capitalized, from UK price paid. If I group by day and I order by, I'll just order it by day so it all kind of fits together. I should do descending because then you get all the old ones. Let's see what the most recent ones are first. That'll be more interesting. So on November 30th of 2023, the most expensive house sold that day was 550,000 pounds, it looks like. And then on the day before that, November 29th, 2023, the most expensive house was 990,000 pounds, and so on. So these date and time functions are, like I said, they're really nice. There's a now function, so you can kind of see what the, you can just select now and see what the current day is. It's February 6th as I'm typing here. I was going to show you some math here. Let me do a couple things. So if I do now as, I'll just call it today, I'm going to select, and it's kind of fun, some of the things you can do. You can say today minus 1, you have to put interval. You can do interval 1 day. Like date math is super easy to do in ClickHouse. So if today was February 6th, yesterday was February 5th. I mean, that's nice. I can take right now and subtract 1 hour, I suppose. So it's 3:30 instead of 4:30. So those are great and nice to know, to be familiar with. You can actually just subtract, like here you can subtract 1, which is kind of interesting. If you say, here I'll do the same one because I like this example. Let me select today and then today minus 1. And you'll see that it subtracts, it was 05, it subtracted 1 second. What does it mean to subtract 1? It subtracts the precision of the timestamp or date, which in this case was seconds. So that's what it subtracted. All right, and I have some other examples here. Check out the docs. Like I said, there's all kinds of date and time functions, so it's kind of hard to single some out. I just want you to kind of see what they look like. All right, so let me skip ahead through some of these. Oh, I like the argmax function quite a bit. I will show you this one, and I have these typed up. If I want the most expensive house in town, it's easy to find the most expensive house in town. I can just run this query right here. Hey, notice you can leave that little comma right there, and ClickHouse doesn't mind, even though you don't need it. If I want to know what street the most expensive house in each town was, well, that doesn't work. And this is not a ClickHouse issue. This is just a SQL issue. I don't want to group by street. Then I'm going to get the most expensive house on every street in every town. I'll get way too many results. And I can't say any street, because any street in town isn't going to be the street in town with the most expensive house. I want the street in town with the most expensive house, and we have a great function called argmax, and you pass in the column that you want, like I want the street, and then you pass in the column that it will compute the maximum on. And so here, wherever the maximum price is, I want the street with that most expensive house. It's possible that 2 houses in Hornchurch sold for £42,970,657, but it's pretty unlikely. And either way, it's still true that the house was on Gladiator Way. There was a house on Gladiator Way that sold for this amount. And so it's cool. I mean, it's kind of clever how it works. I suppose I could figure out the date too. I could figure out the date that it happened based on the price. So then we'd know which day that property sold. So on March 2nd of 2018. Big fan of argmax. There's argmin as well. So check it out. It's in the, check out the docs. You can see my examples here. I think it's a super handy function. I really don't know where to end the conversation. So I kind of just put this slide in here to just say, look, go to the documentation, get yourself familiar with the functions. I do want to show you this clever, there is a table in the system database called functions. And if you look at it, it has 1,478 rows. Now, if you run this in the future, it'll be more. Like this list grows. Every time I teach this training, you can see a bigger number. Notice there's a column called is aggregate. And so if I ask for the aggregate ones, those are the aggregate functions. Out of the 1,478, 180 of them are aggregate functions. So the other almost 1,300 are regular functions. That's a lot of regular functions. It's also a lot of aggregate functions. I mean, 180 aggregate functions. That's a lot of computations that you can do. So we'll go through those. I'll start looking at some aggregate functions here and showing them to you in just a minute. Hey, one topic I want to point out, in ClickHouse, you can define your own functions. You can have a user-defined functions that you define with SQL. And to do that, you need to write a Lambda expression. Lambda expressions, you'll see them in a couple of places in ClickHouse. One of them is definitely with array map. This function takes in a Lambda expression. Here I'm taking in a value and extracting the text from HTML. That sounds like a pretty cool function. Does exactly what it sounds like you think it would. It'll return hello and world without the HTML around it. Here I'm taking X and Y and finding the least common multiple of X and Y. That's, the mathematical least common multiple. So the least common multiple of 7 and 9 is going to be 63. So, that's what it's going to do. And this is like you're defining a Lambda function, but you can't really call that function later. If you need a function and you want to call it later, you can create a SQL user-defined function. And so here I created a function called merge postcode, and I took the 2 postcodes and I merged them together, as you can see. And now I have a new function that I can call whenever I want to. You can see on the example below here, I selected the merge postcode, and it's simple, but I just wanted to show you that and not only is it simple to do, you can see it'll show up in your system.functions table. It'll actually add it to the list. So, all right, so user-defined functions are possible. The aggregate functions are in the next category. In the docs, they're separate. We actually have a page in the docs that theoretically says they're all on there. I don't know how 100% accurate it is. I don't know if there's 180 functions on this page, but it's probably close. So we have all these aggregate functions that you can use, and they're listed here in the docs, and hopefully they're all here. I mean, that's a lot of functions. It can be a bit overwhelming. I mean, there's like I said, the ones that you might expect that you can do a min and max and count and sum and average. And I've shown you a lot of those. I'll show you what quantiles does. I showed you the any function. Like here in this example, I'm getting the minimum price, the maximum price, the sum of all the prices, the average price. That's all perfect and great. And, like I said, these are the sort of everyday aggregate functions that you would expect to be able to run on a data set. If you look at some of the other ones, they start to look like a statistics exam, and this is where ClickHouse really pays off. In my opinion, these functions are what sort of pushes ClickHouse to another level. The fact that I can very easily compute the Pearson correlation coefficient between two columns by simply calling that function is just really convenient, really handy. I mean, I can do population variance, population standard deviation, population covariance, simple linear regression. It very much looks like a statistics exam. For example, I took the hash code of the two postcodes and created a number out of it so I could see if there was a correlation between the price and the postcode. And I did this is the Pearson correlation coefficient. This is Cramer's V. I did a population variance and a standard deviation, a population standard deviation. You can see the values there. Oddly enough, price and postcode, Pearson didn't seem to think there was much of a correlation. It was kind of neutral, almost zero. Cramer's V found a definite correlation between the two. So anyway, for what it's worth, like I said, these are great examples. Quantile is an aggregate function that you take in a column, but you also pass in a percentile. And so 0.9 is the 90th percentile. What does that mean? 90% of the price column is less than or equal to whatever number it comes back with. So in this example on the slide, the 90th percentile is 395. Now this changes on a regular basis. Every time I sort of teach this, I get a different data set because I pulled the data in. So if I do the 90th percent, it'll be close though. I mean, it doesn't change that much. Of the price column, and I spelled that wrong. I'll fix that. From UK price paid, and the current 90th percentile is 405,000. 90% of properties in this data set sold for less than 405,000. Now that's pretty, I mean, this data goes back pretty far, so that's pretty old numbers. If I want to do it from like the year 2000 or something, that might be more interested. So let's see if I can do that. I'm assuming that would be higher. Yeah, 430,000. Well, really, that's not much. Even in like, let's see what 2020 is. Even in the last 4 years, the average price has been 620,000. So quite a bit higher. But it's an interesting number, and you can do quantiles and pass in multiple numbers. You can do like the 10th percentile, the 50th percentile, the 90th percentile, and then you get back three numbers because I asked for three numbers. Half of homes sold for $269,950. They sold for less than that, so obviously the other half must have sold for more. It's an approximation. You'll notice this number is slightly different. The 636 or 350 is slightly different. That function is an approximation of the 90th percentile. Oh, quantiles. I snuck an S in there when I did quantiles. So you get back three values. Same example I just showed you. Hey, I like the unique function. It shows you how many unique values that a column has. This is very much an approximation. These are massive data sets. I mean, I only have 28 million rows, and I say that in a way where some of you might be thinking, wow, 28 million rows, that's the biggest table I normally would have. Well, in ClickHouse, that's not very big. Think about 28 billion rows. Well, if I had 28 billion rows or 28 trillion rows, well, then trying to find out the number of unique values of a column is too much effort. It's very expensive. So this is an approximation, and it uses hyperlog combination of theta sketch. I don't even know what that is, to be honest. I know what hyperlog log is, but I don't know what the other one is. Unique exact, the exact number is 328,548. The approximation is 330. That only took 2 milliseconds, 0.2 milliseconds. It took twice as long to compute the exact value. And again, I have a very small data set. So be careful with exact. We don't necessarily recommend you use it very often. Top K is a great function. I can just run it for you. This is the top street names in terms of occurring values. So if I select top K, I want and we don't recommend you put in a number bigger than 10. So if I want the top 10 street names from UK price paid, I'm going to get back, well, an empty string. So it's missing that's the most common street name is an empty street. High Street, Main Street, London Road, and so on. All right. So those are it's again, not exact. Look, I'm just analyzing data. I don't need to know the exact top 10 street names. This tells me something. This is useful information. And I might be more than happy with this result. One thing I want to show you, this is the first time you'll have seen this. Aggregate functions can have expressions added to the end of them. They're called aggregate function combinators. We have a page in the docs that lists all of them. And there's like 15 or so. What are these? These are terms that can be appended to any aggregate function. For example, take your favorite aggregate function, there's 180 of them, and add the word if to the end of it. And then it'll, like here it says average if, I don't know if you can see that on my slider. That'll be the average of this column, but only for the columns that match the conditional. Hey, that's pretty clever. What isn't so obvious is that I can do that for any function. So for example, if I do top k if, I'm searching the docs right now for top k if, and that function doesn't show up. It doesn't look like there is a function called top k if. I want you to realize that there is a function called top k if I copy and paste this. And you can absolutely put if there and then add a conditional where street is not equal to an empty string. And then it figures out the top 10 street names, but it leaves out all the empty ones. And so there's High Street. Now High Street's number one instead of an empty street name. And I get slightly different streets, but again, it was an approximation in the first place. And what's interesting about that is you can add more than one combinator. So if street's not an array, but if it was, I could do top k array if. and you can add array to any aggregate function. And you need to add array to the aggregate functions where the columns you pass in are array values. And the same for map. You need to add map to columns that are maps. If you want to find the sum of, what's the example here? Yeah, we do a sum of this map. There's a nice example in the docs. So you can add map to any array function. So take the 180 functions that are aggregate functions, add all these different combinators, and there's just all kinds of, there's thousands and tens of thousands of permutations, I suppose, if you put them all down. So they're not documented. And so you just need to understand that you can do that. And I got one last function that I want to show you just because it's kind of a fun one. It's not an aggregate function. It doesn't return one result. It's not a regular function. It doesn't return a result per row. It unfolds an array. It's called array join, but it actually kind of like expands or breaks up an array into different rows. So for example, I can just show you how it works. Look, if I split by char, so the street names usually have like a break in them. So if I split by a space, for example, you can see that I'll get back a bunch of arrays. Oh, what did I do wrong there? Oh, I should definitely put a limit on there. Oh, I got them backwards. Oh, sorry, the character goes first. I did that slightly backwards. Let me put street here. It's telling me that, and I wasn't reading it very closely. Notice you get back a bunch of arrays. Curlew Drive, Church Farm Meadow. These are the 3 strings in the street name. And so it's kind of clever how it does it. You can see the original along with the split by char. You can see how it's creating these arrays. What I want to do is take that result and pass it to array join. Instead of getting back a bunch of arrays, it just takes all those arrays and expands them into rows. Handy. That's all I can say is that it's a handy function. You'll notice it's over here in the functions, and it kind of has its own page all by itself. And we even say it's kind of an unusual function. So I just wanted to point that one out while we were talking about functions. So you have a lot of work to do. You're going to casually, gradually find your way around the documentation, find these regular functions, find these aggregate functions. It's all there. It's amazing what ClickHouse does. You just have to sort of, get comfortable with the docs and get comfortable with searching the docs and really just thinking differently and thinking, hey, I bet there's a function to compute this value or do this clever thing that I want to do, because there probably is. We have over 1,400 functions. So in the lab, you have that UK property prices data. If you didn't insert it in a previous course, the lab instructions will walk you through how to insert the UK property prices data set. And you're just going to write all kinds of queries, lots of regular functions, lots of aggregate functions. I want you to be comfortable with writing queries, because at the end of the day, that's really what it's all about, is analyzing the data. All right. Like I always say, look for us on clickhouse.com/Slack. If you have any questions, there's a ClickHouse Academy channel in that community Slack, and we're here happy to help you. You can also email us at learn@clickhouse.com, and off you go. Good luck.